Last payment, as in last payment, I gave you my mortgage. Now, this is an example used in the other video. It's a very simple amortization table to work out that last payment we have here of 257.89. Now, if you have a recursion statement, that you know that it's $1,000 and you've worked out your recursion statement by connecting these two together, you can see the 1,000 and the 12.5 gets you the 1.0125, and that's your payment that you're making each time. So it's going to be minus, bing, 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 you get yourself just 4 extra cents there to add to that one, and that gets you the 257.89. That's one way of doing it. I'm going to give you a few options on this. Second option, you could do the same thing, but if you didn't have the recursion formula, but they did give you the APR. Now notice that I had about a 5 here. That's different from the 1.0125 for there. So this is a monthly situation, so you had to take the 5 and divide by 4, or get it from here. But if you want to go back from that R, you've got to make sure that because you're doing quarterly payments, you've got to take the 1.25 and times by 4 to get this 5, or you'll fluff things up. Now, again, we just put in our negative for our payment, positive because it's a loan, negative for the payment, press the FE button, and you can see that this number and this number are pretty damn close, or exactly the same, and then you add them together. All right, and now it looks like a minus and a minus. No. Just add them together. All right, so a negative plus a negative gets you an even bigger negative. It'll get you minus 257.89. Another way to look at this is if I wanted to work out what my third payment was. I didn't get the amortization table. I get this third payment. Well, I can work out what the third payment is, and I can see that it's 254.71, which is that number there. And then I can imagine I am just doing a loan starting at this point going to here, which is one payment. So imagine I'm just doing it for one payment now, and you can see I've done one payment at 5% of $254.71. Final value is going to be 0, PY and CY are 4 because it's quarterly, it's paid off in 1 year. And so I did the N of 1, I of 5, borrowing $254.71, press the PMT, and I did get minus 257.89. So that's another way of doing this, showing you lots of options so that you're sort of a bit more bulletproof when you hit an exam. All right, so imagine you're trying to buy a house that's worth $1 million. You have to borrow $800,000 because you're a good person with a good LVR, which means you can qualify for Athena Home Loans and get 1.99%, which is probably the best on the market. I don't actually bank with them, but I did ring up my bank and said, hey, give me the same rate as Athena or I'm leaving. And guess what? They did. So that's pretty good. Now, first question is, based on this information, what are your payments? And you just plug that into your financial solver. So we've got 30 years monthly, so it's 360. Remember, you can just type in 30 times 12 into that part of the bar. Our APR is 1.99, nice one, so it's not that annoying thing off the amortization table. Present value is 800,000, final value is 0, PY and CY are the same, and they're 12 because of the monthly word. And click the button, and we get 2952.96. So make sure we write that number down. It's what are your payments? 2952.96. Stick a dollar sign. Do not put the negative sign. I mean, a payment. The negative here is just showing the directional flow of the money. Obviously, you know which way the payments are going. They're going to the bank, so you don't need to put that negative. Let's have a look at some ways of looking at that last payment. Now, you are not going to do a recursion for 360, so you can't do the recursion technique. So let's have a look at a couple of ways of doing it off the financial solver. You could do that thing where you go to the 359th payment and work out how much you still have to pay off, and then you can plug that final value back into the present value and then just do that one payment, just like we did before where we worked out the third payment to give us the last payment of the fourth one. We're working out the 359th payment and then going to borrow this money for one time period. So that's what we've done here. So we took this 2946.52, put it up here, as a loan that we're borrowing, and we're just doing it for one time period because we need to go from 359 plus 1 to 360, and press the FV button, and our payment is 295.41. All right, so how much is the last payment? It's sometimes called final payment, I think, on the exams. Same thing. 2951.41. So remember, because we took this number, which is 0.956, and we had to round it up to 0.96, that means that we've actually been slightly overpaying for 359 payments, and that's why this number is less than this number, if that makes sense to you. Another quicker way, perhaps, of doing this is just to go, look, I've got 360 payments, 199. I know my payments now, and I hit the final value, and I get $1.56. Now you add these two numbers. That's a negative number plus a positive number, and you'll actually get a slightly different number. You'll actually get, if you do that, because you get the 5, 6, you can see the 6's cancel out, so you'll actually get 2951.40. Only a difference of 1 cent. You can see that there are sort of rounding errors that creep into things, very small margins. That won't be a thing on an exam. So when I looked at, there was a past exam question, if you look through my past videos, which had this issue, but what they did as options, they weren't differing by 1 cent. All right, so don't panic if you're going, but it's 1 cent difference. Am I going to get this wrong? No, it won't be on the multiple choice like that. Okay. I prefer this first technique. I think it's a bit more resilient sort of thing. But on the options on the exam, it might have been something like the actual 2952.96, obviously, or 2946.52 would have been another option. All kinds of things like that. But people often fluff up the final payment calculation, but either of those would have been fine, including on a SAC.